What's up, guys? We're going to do a quick lab, quick stoichiometry lab. So first up, we have all our lab materials out. Got our 4 molar HCl and our 4 molar NaOH. We have a 500 milliliter beaker and a balance. First step, we also need to have our lab apron and goggles on. Goggles. Oh, jeez. Alright, goggles are on. Now we get the lab apron on. Alright. Second step, we will mask the 500 milliliter beaker that will contain the HCl. Here's the bounce. Wait. Oh, looks like it's done. It's about 21.20 grams. Alright, so now we have the mass of the beaker. Next step is to pour 250 milliliters of the HCl into one of these beakers. Okay? Now this is a dangerous chemical, that's why it's the red cap, and because it's a dangerous chemical, I'm not going to show this part on screen. Alright, 250 milliliters of HCl, 4 molar. Now we have to get 250 milliliters of 4 molar NaOH in another 500 milliliter beaker. Now, I won't do this either because NaOH is also a dangerous chemical, so I can't do it on camera. Boom! And then we also have to label which beakers each. Okay, so bang, paper, whip out that pen, NaOH. See? Put it with this one. I fell over. It's okay. We can see it. I can see it at least, so it's a good part. And we also have HCl. See? Put it for this one. Cool. Now we have our labels. Now, next step, carefully pour the NaOH into the beaker of the HCl little by little because you want to make sure it goes like drip by drip to make sure they're fully reacted. Ooh. Here we go. Now, because I'm a professional, I can do it fast, but you guys have to do it slow. Bang! Booyah! So now we have the final 500 milliliters of solution of combined NaOH and HCl. And we know that reacts to create NaCl and H2O. So essentially it'll be salt water. Now because it's salt water, it's safe to drink. And I trust chemistry so much that I will completely drink this. No, I'll drink a little bit. It's a little bit. So our final yield will be a little lower than usual. Okay, it's a little salty. It's a little salty. Yeah, it's pretty salty. Okay, so now we will let these evaporate until only the salt is left. Ready? Boom! Wow, the beaker changed a little bit, but bang! There we go, there's only the salt left. And we already have the mass of the beaker too, so we can just mass all of this right away and just subtract the mass of the beaker, so it's a W. Alright. I can't see. Ooh. It's a little foggy in my goggles. So now we will measure the mass of the combined beaker and salt. Mass. Wow, we put the salt on. Beep boop pop. Take the salt off. Bang. 78.9 grams of the salt plus the beaker. And if we subtract that from the mass of the beaker, which this was the mass of the beaker and this was the mass of both, we can get a whopping 57.7 grams of salt in this cup. No, not cup, beaker. Okay, so now we have the mass of the salt produced from the experiment, and now we need the theoretical yield of salt, which we will do stoichiometry, and we will find the percent yield of NaCl2 in the next part of the video, and we'll do a quick cleanup. You don't have to see that.
What's up, guys? Time to do the stoichiometry to get the theoretical yield, and then we can get the percent yield from the experiment. So we do the theoretical yield first. Yield. We had 250 milliliters of HCl. And we had a 4 molarity HCl solution, right? Sorry if it's a little bad looking. And it had 4, so 4 molarity means just 4 moles per liter, so 4 moles per 1,000 liters. So bang. And we do this, 250 times 4 is 1,000, 1,000 divided by 1,000 is 1. So we had 1 mole of HCl. So now we have 1 mole of HCl, and now we use the coefficient ratio between HCl and NaCl to get the ratio, yeah. So we know that the equation, balanced chemical equation, is HCl plus NaOH turns into NaCl plus H2O, which means 1 mole of HCl turns into 1 mole of NaCl, so the ratio is just 1 to 1. So that makes it a lot easier. 1 mole of HCl, 1 mole of NaCl, and then we know the molar mass of NaCl for our purposes will be approximately 58.5 grams per mole. So our theoretical yield of NaCl will be 58.5. Ooh, it's a little wonky. 15.5 grams of NaCl. So 58.5. So we got from our experiment 57.7 grams of NaCl. So that's a little lower, which probably because I drank a little bit. So that would be a source of error. So then we have 57.7 grams of NaCl, divide that by the theoretical yield we were supposed to get, 58.5 grams of NaCl. And if we want that in a percent, we multiply it by 100, which is equal to, so let's whip out our trusty calculators. We do 57.7 divided by 58.5, 58.5, times that by 100, we get about 98.6%, which is pretty good, 98.6% yield. Not a full 100 because we drank a little bit, so a source of error, but 98.6%. So there you have it, the theoretical yield and then the percent yield. Thank you for your time.